Okay, so in this problem we're taking uh, the y equals x squared graph, but this time we're revolving it about the y-axis as opposed to the x-axis. So that's going to generate a different shape. That's going to generate a different shape for us when we do it that way. Because what we'd have gotten if we revolved about the x is we would have gotten that weird horn shape. But now we're taking this graph between 0 and 4. So I just have the whole graph there. But it's being revolved. And so that's going to produce this bowl type shape. Now, because we're revolving about the y, we need to think of an integral in terms of y. Right? We're integrating along the y now. So what we recognize here is if we're going between 0 and 4, we have to look at this in terms of y. And so we draw in our little rectangle here, like so, about the y. And we can see that that little rectangle, that'll be the thing that becomes our cylinder, right, our little cylinder, about the y-axis. And so we have to integrate with respect to y. Well, that means that we're going to be integrating along the y from starting down here at the bottom, where the graph starts, up to whatever this y value is at the top. Well, if it was from x equals 0 to 4, then the y value up here in the top would be 16. And so we're going between 0 to 16. And then the other thing we have to do is, if we're integrating with respect to y, then the function needs to be solved for x. So we take our y equals x squared, and we solve for x by applying the square root of both sides. And get that the x graph we're dealing with, which again is only this portion of the graph, positive side from 0 to 4, right, from 0 to 4, it's just the positive x squared part of the graph, is the square root of y. Okay, and so with that in mind, we are ready to go now. Volume still works the same way, except now we're revolving about the y, and that's why we have to use the disk that has the y height here as the radius. Okay, so we're ready to go. Volume is the integral from 0, between our limits, 16 of pi times our function squared. So that would be square root of y squared dy. That means that we're dealing with pi integral 0 to 16 of the integral of y dy, which means we're dealing with pi over 2 y squared between 0 and 16. And then it's just a case of evaluating that. You plug 16 in, you get 16 squared, which is 256, times pi over 2. This thing has a volume of 128 pi. 128 pi. Okay, so hopefully it kind of gives you a little feeling for how these volumes work, where we've been using disk. But what if we want a shape like, what if we wanted to take this bowl shape here that we have, and what if we wanted to like drill a hole down the middle of it? Right? What if we want to take some part out of it? So a shape with a hole in it. Well, then we have to deal with not a cylinder, but rather with a cylinder with a hole in it, which is actually going to be what we call a washer. If you've ever dealt with any kind of screws and stuff, remember, I'm making it look kind of thick, but these things that we're dealing with here have a very, very small thickness to them. In fact, as we do the integral, we let the thickness go to 0, right, when we take that limit. And so what we're going to be looking at are like those little thin washers that you put on. You put bolts and screws on. So that's what we're going to be looking at in our upcoming examples.